Hello everyone, I'm Lucas. So today I'll be going through the 2025 May 15 of IB time zone 2. So according to some of my students, I think this time zone is one of the hardest papers. So therefore, I spend a little bit of time to go through this particular paper in general. So this is basically a leak paper, so therefore it's not published officially in the IBO, so therefore this doesn't really have a mark scheme at all, so this is just a suggested answer. Okay, so I might got something not wrong, so therefore if I got something wrong, please let me know in the comment section down there. So I will go through some of the thinking process of this particular paper. So I think I will spend around 30 minutes to go through section A. So we have 9, right? I think 9 questions total. Okay, so let's say for 5 minutes reading time, I'll look at the first question. So the first question is like a normal differentiation question because I see a minimum point, something like that. So might as well, let's try to time myself now. So now it's like 9:48. So let's begin. So function f, it's here, and they give you a minimum point as well, and also they gave you p is bigger than 0, so probably might be useful later. Find p and q. So 5 marks, right? So I'll just differentiate that directly. So this will be 4x squared minus 16. So since there's a minimum point, right, then I'll make this equal 0. So then we have 4x squared equals to 16. Divide both sides by 4, you get 4. So plus minus 2. But since we know that p, which is the x coordinates, which is bigger than 0, so we take p as 2 as our final answer. So of course we want to find q, right? So q will be found by plugging in 2 into the original equation. So 4 times 2 cubed over 3 minus 16 times 2, I think. Okay, so this will become, so let's see, 4 times 8, 32, I think, minus 32. Okay, so combine the same fraction. I think this is the same as, so 3 times 32, 3. So factorize the 32, then I got 32, 1 minus 3, or 3. So I think I got, like, this is negative 2, so negative 64 over 3, I think. Okay, so something like this. So might be ugly, it's okay, I'm just trying my best to speed run the whole paper. So I think that's the first question already. 5 marks. Just make sure that at the end I will check this again, okay, if I got remaining time. So easy. So next one, compound interest. When I look at it, so $1,000 in the normal interest rate of 4% quarterly. So write it back as 1 plus k power 4. K is a rational number, 5 out of k. This is a bit cheeky, actually. So if you recall in the formal booklet, PV 1 plus R over 100k, Kn, right? So there's the formula. So obviously PV is 1,000. And then R would be 4. K is the compounded period, which is 4. But be careful is that the k in here and the k in here are actually different. So therefore, just be careful. And then any more? N it's like how many? So N is what, like how many? 4 years, right? Okay, power 4 in 1 complete year. So N would be 1. Okay, so I think I got everything. So FE equals to 1,000, 1 plus, or it's 4 over 100k, power of Kn. So K will be 4. Okay, so that's the same thing as like how many k, right? So k 4% quarterly, so cancel. I think it's like 0.1, right? I think so, 0.01 power 4. Okay, so I think that's basically the value of k. But this is actually a little bit like not trivial. Part B, so k would be 0.01. So expand this, right? So this is a Pascal triangle. So the fourth row, 1, 4, 6, 4, 1. Then if we expand it, it'll be 1 plus 4x plus 6x squared plus 4x cubed plus x power 4. I think so. 1, 4, 6, 4, 1. So yeah. Find 1 complete year and correct to a near Steiner. So Steiner, right? Okay, so let's see. So expand it, right? So let's try expand it. So since we are going to expand this one, so I want to find this, right? So it will be 1,000, and then what we need to do is just plug like x as 0.01 because like we know that this is x and this is k, right? So all we need to do is just put x as 0.01. So 1 plus 4 times 0.01 plus 6 times 0.01 squared plus 4 times 0.01 cubed, and then 0.00, so that's like 0.01 power 4. Okay, so let's try expand it. Okay, so there's like 4 plus, sorry, this is like 1 plus 4.0, sorry, 0.04. Okay, and then this will be, so 0.1 squared, so it's like 0.0001. So this is 0.0006. The next one is 0.000004, 0.1232324. Okay, something like this. So we expand it in. So let's try to combine inside first before expanding. 1.04060401, right? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 zeros at the end. Okay, so we don't have 1,000. It'll be 104.604, I think. Okay, so I think that's basically the answer for 0.601. Yeah, I think so. So I think this is cents, right? There's like 10 cents. This is cents. I think this is a diner, right? Hopefully I got this correct. Okay, so C part, 4 marks. Wow, this is actually an interesting question. Area bounded between the curves, right? Between this and this. I think this is pretty easy because we know that E, it's like this, right? And negative E, it's like this way. So we want to find the area between -1 and 1. So we want to find the area in here. So same thing. So what we need to do is just integrate the upper curve minus the lower curve. But they're the same, right? So, and then this will be -1 and this will be 1. So when you expand it, it will be -1 to 1, 2ex dx. Okay, give me a second. So let me grab water. Sorry about that. So if you integrate, it'll be let's see. So -1 to 1. When you integrate e, it's still e, right? So 2ex, -1 to 1. If we expand it, it'll be 2e minus 2e -1. So we want to write about it like this. Okay, and I think that's basically it for this question. Hopefully I didn't get any silly mistakes. Okay, yeah, I think so. So done already. Pretty easy, this one. So next one. Probability events. Consider events A and B such that A naught equals to this and equals to this, right? And this equals to that. Find A and B. So I will use the formula first. A or B equals to PA plus PB minus PA and B. And then next one, we'll look at the marks, 3 marks, right? So I think I need to do some algebra here. So this is my first equation. The second equation, I will use this. Since they give you that, then this will be PB given A, which is PB and A over PA. Okay, so this is something that we need as well. So this will be a second equation. So we want A and B. So it's like this part, right? Oh, sorry, this should be A and B. B and A. Here, right? So I want this one. I want this one, right? Or this one, doesn't really matter. So what we need to do is, since they gave us this equation, let's start with equation 2. So PB and A, right? So PB and A is 2/3. So 2/3 equals to PB and A, or A and B doesn't matter. PA would be, so since they give you PA naught, right? So which is 3/4. Then remember PA naught is the same thing as 1 minus PA naught here. Because like we know that this is PA, right? PA and PA naught should add up equals to 1. So if we want to reverse it, it'll be 1 minus the naught of A. So then this becomes, I'll just flip the top. Okay, so 1 minus A naught. So A naught will be 3/4. So I think that's basically it. So multiply that to the left. Then 2/3 times 1 minus 3/4. So 2/3. This is 1/4, I think. So cancel number before we move on. So 2 and 4 cancel, becomes a 2. So 1/6, I think. Okay, so part A done. Part B. Show that A and B are independent. So A and B are independent, right? So meaning that we want to prove PA times PB equals to PA and B. This is something that we want, but of course we cannot assume that this is the case, right? So we just start with PA times PB first. So PA, I think we got already. So PA would be 1 minus 3/4. PB. Okay, so PB, I think we need to use equation 1. Okay, we need to use equation 1 here. So PB. Just write equation right here. So PA or B, we got it's 3/4, right? 3/4 equals to PA. PA is like 1 minus 3/4. And then PB, we don't know. Okay, and then minus A and B. I think we have A and B already, 1/6. Okay, so we need to find PB first. So 3/4 equals to, this is like 1/4 PB minus 1/6. So move everything to the left, let's say, then this will becomes, so move the 1/4 to the left, and this is 2/4 or 1/2. And then plus 1/6 equals to PB. So actually they asked us to show that, so it's obviously we know we're right or wrong. So this is 6, so this is a 3. 3 plus 1 is 4, so 4/6, which is 2/3. Okay, so this is 2/3. So 1/4 times 2/3. So moment of truth, 1/6, right? So because like these cancel out, 2 times 3, 6, correct. So this is it, and PA and B from part A, it's also 1/6. So therefore, PA and B equals to PA times PB. So therefore, independence. To be honest, this question is pretty easy. So I think this is SL, right? Okay, so 3 marks, 3 marks. Okay, sequences. So consider sequence with 10 rectangular picture frame. Picture 1 has a width of 4 and height of 5. And then each side is increased by 50% to generate the next frame, which is called Fn+1. Okay, so basically, right, I think we just need to find the height and the length separately. Okay, so width of 4, right? Sorry, it's width, not length, width. Okay, so the heights, right? The height is 5. So we know this is geometric sequence because this is increased by 50%. So we can expect that the height nth term would be 50 times the ratio, which is 50%. So increased by 50, so 1.5. Okay, 1.5. I think a lot of students will get this wrong already. Maybe they will write like 0.5. And then n-1, right? Since we know that this is a fraction, so I'll write this by as a fraction. So 50, 3/2, n-1. The width will be 4 cm, right? So 4. Sorry, it's like not 50. This is like 5, right? Sorry about that. 5. This is 4, and then same thing. You're going to add 50%, right? So 1.5 and -1. So same thing. So 4. Sorry. Write the question wrong. 3/2 and -1. So the area, right? So Fn, like the area, will be this one, and then times 4, 3/2 and -1. Okay, so we expand it. So 5 times 4, 20, and these two are like terms. So basically, if you multiply these two together, what you need to do is these two things, it's being squared, right? So squared, if we apply inside in the brackets, it will be 9/4. Okay, So since they gave you an answer, so it's pretty obvious is that you need x squared inside as well. So part A1. Find the mean area of a 10 picture frame. So mean is like add everything up and then divide by like the sum of Sn formula, right? I think. Because like this is a geometric sequence. So Sn. So U1, 1 minus R power of n, 1 minus R. So U1, which is the first term, so we plug 1 inside. It's basically 20, so 20. And then 1 minus ratio. Ratio is 9/4. Power of, how many do we want? 10, right? So we want 10. Okay, this might be hard. Okay, so it looks something like this. Even with a calculator, right? So, okay, so what do we need? So we want to write it back as this form. So they gave us a, okay, so we don't need to expand the whole thing. We just write it as this form. So at least we almost got it. Okay, so since they want 9 power of 4 minus 1, right? Then I will swap the top and bottom. So we got 9/4 power of 10 minus 1. The bottom, I think we can combine them together. So 9/4 minus 1, which is 5/4, I think. Yeah, okay, 5/4. So basically flip the top and the bottom. So if we keep on canceling it, so this would be gone, so 4, right? So it'll be 16. Okay, and what we need to do is we need to also find a mean, right? So the mean is like add everything up and then divide it by the total number of data points. So divide by 10. So basically divide this by 10, right? So 1.6. Or basically, since we want to write a fraction, so 16/10 of the whole thing here. Okay, so simplify further. So 16/10 divide top and bottom by, I don't know, like 2. 8/5, I think. So 9/4 power of 10 minus 1. Okay, I think this is like pretty hard to be honest. I think that's also in the essay question, right? Well, 5 marks. Okay. Interesting. Okay, find a median area of the frame. Give an answer in terms of this. So median, right? So let's say if we got 10 things. So let's say 1, 2, 3, 4, 5, 6. So let's say so basically going towards F10, right? So just write this out like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So median, right? So median would be going to the left, going to the right, and converge to the middle, which is 5 and 6, I think. So what you do is we want to find the midpoint of 5 and 6 as well. So we want to find F5 and also F6 first, okay? So we want to find this. So how do we find F5? Put 5 inside, I think. So F5 will be 20, 9/4 power of 4, and F6 will be 9/4 power of 5, okay? So what do we need? We want to write it like this. Okay, so the median, it will be these two add together. And then divide by 2. Okay. So what we can do is maybe we can factorize something out because we want to factorize this, right? So first of all, to factorize the 20, factorize the 9/4 power 4. Then we'll have 1 plus 9/4 over 2. Okay. So I think the question allows us to have 9/4 power 4, right? So we just skip it right in here. Then what we need to do is we need to combine this, and this together. So let's see. 20/2, that's like 10, right? And then 1 plus 9/4. That's like how many? I think, let's see. So 4, I think like 13/4, right? 13/4, and then we need to times this by 10. So 13/4 times 10. So cancel it, it will be 13, that's like 5, right? Divided by 4, so that's like times 5 over 2, I think. Okay, so 13 times 5, I don't know what is that. So 13 times 5, 15, 5, 6, 65 over 2. So this question is also something I need to check because like the algebra side is actually pretty crazy. But I would say the first 5 questions is actually harder than the normal AA paper already. So therefore the petition for lower grade boundaries is like, I think it's like kind of like reasonable. So I think, yeah, which is pretty hard, like not trivial, I would say. Vector. So number 6 vector, number 7 it's a complex, number 8 it's a MI, homogeneous equation. Okay, I think section A is okay up until this point. So vector equation and this one, so they gave us 2 equations already. Line 1 and line 2 perpendicular. When I see the word perpendicular, I know that the direction vector dot together will be 0. But there's a trick here as well. There's like no I, right? So 0I. So be careful. So we know that 0, A1 dot 1, 2, 3. Immediately we know this is 0. So this was 2A plus 3 equals 0 directly. Okay. So and they intersect at a unique point. So unique point meaning that if I write it back as a vector format, so 4, 0, negative 1 plus lambda 0, A1. And this would be I, J, E, K. So I is 1, J is 0. This is negative B plus mu of 1, 2, 3. So this is like the equation of their vectors, right? So 6 marks. So since they intersect unique points, meaning that the x should be equal, right? The x should be equal. So what you need to do here is maybe let's make the x's equal first. So 4 plus 0 lambda, so nothing, huh? So in the right hand side here will be 1 plus mu. So we know that mu is 3 immediately. Okay. So mu it's 3. And then maybe we can use this y to help us. Y would be in the equation above 0a lambda equals to this one, right? So 2 mu. But since we know mu it's 3, x would be x would be like 6, right? I think we have like a already. Oh, never mind. I think we have a already in here. So a would be negative 3 over 2, I think. Okay, so yeah, a would be negative 3 over 2. So not x, sorry, this is lambda. So since a is negative 3 over 2, this one. So if we make them equal to the other side, then this should be negative 12 over 3, right? Which is negative 4. Times 2 both sides, divide both sides by 3. And put a negative as well. So lambda will be 4. So this one, you got lambda, I think we have everything, right? So z would be negative 1 plus lambda, so minus 4 basically. This is equals to negative b plus mu times 3. So mu is 3, right? So 9. Okay, so move the number a little bit. So 9 plus 5, which is like 14. Okay, I think this question is like not really that hard, but just be careful. Perpendicular intersecting point, so they're sharing the same point, right? Okay, so hopefully okay. So 14 and negative 2 over 2, 3 over 2. Complex number. Well, this seems like half disgusting. Because when I look at this is like kind of disgusting. Write integer 3 as e to the power of a. Okay, so I think this is pretty easy. So 3 is the same as e, right? So e ln 3. Okay, so this is also in your formal booklet, so make sure you know how to use it. Give an answer of the top. This is a complex number, right? Find real part. So 3i minus 1. Obviously, we're going to use part A. So we have z e ln 3. This is the 3 part, and then I minus 1. Okay, this is like 3 part. So okay, so it's like ln 3 I minus 1. So recall your Euler's form. So ei theta, right? So this is the what you do is ei theta is same as cosine theta plus I sine theta. Okay, so this is like the conversion of Euler form. So we need the theta in here. Okay, so maybe we can expand it in. So we got Sorry, there's R as well. My bad. Okay, so we need to find theta first. So this would be EILN3. Okay, which we got the theta already, but we have excess part, and then minus LN3, right? So obviously, this is theta already. Okay, how about the LN3 here? So LN3 here is the same as, so we can write it like this. This is actually the argument. Okay, so ELN3 is the same as 3, right? So we have EILN3 over 3. So therefore, 1/3 apply right hand side will be cosine ln3 plus I sine ln3. Okay, and I think that's basically it. So one real part, right? Real part will be this one. This is the real part. So RE C 1/3 cosine ln3. Okay, so let's look at it, see where they're the same. So yeah, I think so, right? So I think this is highly, like, very accurate already. Okay, and then real part of that, right? So Z, so let's go to here. Z is this part, right? We stop it here. But this time we want 1 over Z, right? So I think we need to use conjugate in here. So, okay, let's see. So negative Z, right? So Z and then -1. I think we can go in here. We'll start in here again. So Z would be 1 over 3 E I ln3, and then we'll -1 this one. Okay, so inverse this one will be 3, and then power to power can, like, negative. Okay, so I think that's basically it. So 1 over Z will be the same as 3, and then cosine theta -3 plus I sine -ln3. Okay, so real part, right? Real part, we want this one again, this one. So, but what we wanted to remind you is cosine is an even function, so therefore negative inside same as no negative at all. So therefore, the real part of it, 3 cosine ln3. Okay, so that's basically it. This one I think is not really that hard, okay, but it's kind of tricky because I never ask a question like this. Okay, just be careful, make sure you understand order form. Actually, I think this is a very good question because I normally would not, we rarely do with orders form, right? But they force you to write this way, so therefore I think this is a very good question in general. Okay, good question, good question. Number 8, logs. Show that, okay, so they gave you a claim. Show that this is the case. So actually in IB, you can just directly start in the question. So 1 plus, so just right away consider 1 plus log 2n bigger or equals to log 2n plus 1, right? So see where this is correct. So maybe we'll move the log to the right. So we got log 2n plus 1 and then minus log 2n, right? So maybe we can also, like, use a log rule and see where this is always true. So if we look at here, right? So this one, so n and then 1 plus n. Is this always true? Show that this is the case. Okay, let's see. So this is the same. So let's try to, like, expand the fraction a little bit. So 1 plus 1 over n, right? Okay, I think this is, like, pretty stupid already. So I think this is always true, right? So since 1 plus 1 over n, it's always less than, can it be equals to 2? Hmm. 1 plus 1 over n. So when you prove this, right? For some n is a positive integer, so if n is 0.5, wait, never mind, positive integers, right? Okay, so then n could only take like the least value could take 1, right? And then will be 1/2, 1/3. So as n increases, this thing will keep on being smaller and smaller. The biggest one will be when n is 1. When n is 1, then there's like 1 plus 1/1, which is 2. And log 2 is 1, which is perfectly in the sense. So therefore, this will be always smaller than equals to 2 when n is a positive integer. So therefore, log 2 of 1 plus this one. So like the maximum value of this will be 2, right? So the biggest value will be 1 at the end. Okay, so therefore, I think that's okay. And then part B shows MI to prove that this is valid. So for n equals to 1. N equals 1 is basically put 1 inside, right? So put 1 inside. Put 1 inside. It's like 1 in the left hand side, and right hand side would be log 2 1. Okay, log 2 1, which is like 0. So obviously 1 is bigger than 0. So therefore true for n equals to 1. Okay, and then assume n equals to k is true. Then what we got is k bigger than log 2k. Okay, so for k it's some positive integer. Okay, and then consider n equals to k plus 1. So basically apply inside. This is the left hand side, this is the right hand side. So log 2k plus 1. So which one's bigger? I think we got that already, right? So 1 play plus 1 in here. Okay. Okay, so let's try in here. So k is bigger than this, right? So if we use the assumption plus 1 to both sides, then this is the same thing as k plus 1 is bigger than log 2k plus 1, right? Because like what we need to do is just add 1 to here, add 1 to here, and this is basically the assumption on top. So this is like from assumption. Okay, so in the end we want to look at which one is bigger. So is this bigger or is this bigger? Log 2k plus 1. Hey, you can see it, right? And log k plus 1. Oh, it's basically here because once we replace that k, it's basically the question. So log 2k, and if you want to put a 1 plus in front, it's always bigger or equals to log 2k plus 1. This is from part A. Okay, so therefore k plus 1, which is bigger than log 2k plus 1, and which is bigger than log 2k plus 1 inside. So implies k plus 1 is bigger than log 2k plus 1, which we proved the answer already, because like this is the result that I want to prove, right, by replacing k plus 1 inside. So true for n equals to k plus 1. Okay, I think that's basically it. And then at the end, just write out the conclusion, but I'm like half lazy. So that's why it's a 5 marks, because you proved the induction part in part A. Okay, so I think that's basically it. Alright, last question of the video, and then we'll go through the section B later. So it's a homogeneous problem. So actually this question I think pops up over and over again in the further math back in like the old syllabus. So therefore this is pretty trivial, I would say. So use a substitution of y equals to vx, show that the whole equation could converge to this. Very typical. All we need to do is we want to force some y equals to vx first. So we want v to be y over x. This is like the logic behind, right? But the problem is that we don't have y over x. It's okay. Divide the top by x, divide the bottom by x, then you will have 1 minus y over x over 1 plus y over x. Okay? So, and then we use the substitution, so y equals to vx, right? If we differentiate, dy dx will be x dv dx product rule plus v, right? Because product rule the v, dv dx, and then product rule the x will be 1. Okay, so I think that's basically it, and then we just sub everything inside. So dy dx is the same as x dv dx in the left v. The right hand side of the fraction becomes 1 minus v over 1 plus v. Okay, pretty trivial. And then we want to try our best to make the v as one side. Like that, okay? So x dv dx equals to 1 minus v minus bracket, I think it's like a v plus v squared. Okay, it's okay to give you a show that so we know whether we're right or wrong. Okay, so minus v, so 1 minus 2v minus v squared, 1 plus v. So make the v as the left, so 1 minus 2v minus v squared, 1 plus v dv. Right hand side will be 1 over x dx. By the way, right hand side will always be 1 over x for homogeneous. And then we integrate both sides. So is there an easy way for us to do it? I think we need to use u sub in here. I think we use u sub, to be honest. I used to use sub on the left. So let u equals to 1 minus 2v minus v squared du dv minus 2 minus 2v. Okay, so dv du over negative 2 factorized 1 plus v. So and then you plug it in 1 plus v over u, right? And the dv becomes du over negative 2 1 plus v. Cancel it. So therefore you have negative 1 over 2. And then integrate the 1 over ln u. Okay. And then equals to the right. The right will be ln x plus c. Okay. So, and then we want to write everything as one side, right? So let x and number on the right. Okay, so let's change this back into a y over x scenario. The right hand side, what we can do is we can write this back at ln x plus ln e power c. Okay, and then remember this is actually just a constant, right? So we can just erase this and just put an a in here. Okay, that's also okay. So this is the same as ln ax. As long as a constant, it'll be fine. Sorry, this is absolute. Absolute. So y over x. Actually, to be honest, if the question didn't force you to write absolute, you can just ignore it. Oh wait, right, x is bigger than 0, so we don't need absolute in the right. Oh. Okay, so and then maybe what we can do is move the 1/2 to the right. So we got ln y over x equals to times negative 2. So negative 2 ln ax negative 2 as a power. Okay, so you can cancel out ln, right? So we have y over x equals to a over x squared. Okay, so almost there, right? So we have some y's square as well. Okay, so let's see, did I miss anything? Oh right, sorry, my bad. My u is this one. All right. Okay, so maybe I need to change this one. Sorry, I forgot, like the u is the thing that let it start. So this is actually v. Okay, sorry. This is actually still u. Let's just let us u first, like, because like time's long. Okay, and then let's change the u back. So u, it's the 1 minus 2v minus v squared, right? And then ln a over x negative 2. Actually, it still remains the a on the top because a constant when you power negative 2 is still a constant. Although it's in the bottom, but it's still a constant regardless. Cancel ln, so no more ln's, and then you change all of them back as y over x. Sorry, this is like 2 in the bottom. Okay, I think the question is basically done. And then what we can do is we can multiply the whole equation by x squared to get rid of like the denominator. So we got x squared minus 2xy minus y squared equals to a. And then we got a condition, right? So let's see what it is. Well, basically the same. So therefore, that's done already. At the end, we just need to plug in 2 and 0, solve for a. So x is 2 and y is 0. So 2 minus basically 0. And then minus 0 A, right? So A will be 4. So I think that's basically it. Okay, and I think that's the 8 marker here. I think this is actually pretty trivial. If you've gone through some of the old syllabus for the math problem, this is like pretty trivial homogeneous question. It's always like, I think there's like 3 or 4 questions of this already. Okay, so I think section A, to be very honest, I think it's like, I think 7 is a little bit like kind of weird, but I think it's like actually a good, very good question. In terms of difficulty level, I think there's like maybe a 7 out of 10. Not extremely difficult, but it's a kind of annoying. I think this question is like very annoying. Okay, so I think this question is also in the SL, which is, I think for SL student would be kind of hard to do. Okay, so this is basically my solution for section A of paper 1 times on 2. I'll move on to paper 2 later. Okay, thank you very much.